Hello, my dear friends and my dear students. Assalamu alaikum and welcome back to top lesson for you. Dear friends, as you know that we are discussing about the structure of the human eye. So we are now again with a new lecture regarding the structure and a very important part of the human eye, that is the eye lens, right? So we are right now discussing about the eye lens. Now before that we have discussed that we have discussed about 23 lectures I have recorded about the structure of the human eye. We discussed about the sclera, then we discussed about the Uvl track, right? And then we discussed about the retina and all the important points and the structure of the retina we have discussed. Then we also discussed about cornea, about iris, about ciliary body. Done. Now we are discussing, as you know, that about lens. So look here, friends. This is the eye lens which is located in your eye. Where does it located? It is located interior or in front of the vitreous body, right? As here is your vitreous body and behind the iris. So this biconvex part of your eye which is suspended by these suspensory ligaments or zones of zonules, right? The zonules. So this part of the eye is called the lens. Now let us discuss about lens. What is lens? Look carefully. Let me make a diagram here. First of all, a very simplified diagram of the human eye. For example, this is your eye and this is your optic canal, right? And you know that here is your cornea, right? This is our cornea. Then you know that there is your Uvl track, right? We just remind our previous lectures a little bit so that not to forget any structure. This is Uvl track, and you know Uvl track has three subparts: the ciliary body, the choroid, and your iris, right? And then in front of this Uvl track you have your retina that I have fully discussed in the previous lectures. I hope you have watched those lectures and you have learned many things regarding the eye. And this is the optic nerve leaving your eye, right? So all the fibers coming from the retina. Then in front of the retina, my dear friends, you know that you have the vitreous chamber or vitreous body. So if I draw it correctly, I hope I draw it correctly like this. So this structure is your actual vitreous body. Now let me correct it. This is your vitreous body. Now you know that this part is our iris, right? And this is vitreous chamber or vitreous body. Now listen carefully. In the vitreous body, you know you have this small depressed part, right? This depressed part of the vitreous body is called the patellar fossa, right? What is this part? This part is your patellar fossa, right? So where is your lens exactly? So our lens is exactly located in front of the vitreous body and behind the iris in the patellar fossa, held by suspensory ligaments on all the sides. Now if you draw this diagram from interior side, how will your eye look? Look, this is your eyeball, right? And then you have your cornea, and we have taken out our cornea and we are looking at the iris. We have cut it off all the iris and we are looking at your lens. So this is rounded structure. This is your lens, right? And this lens is from all the sides held by these suspensory ligaments. These are suspensory ligaments into the ciliary processes, right? These are your ciliary processes. This is ciliary body processes. Right, like this. So this is your lens. Now in front of the lens, you know that from ciliary process there are what? There are iris, right? So all of these are iris, right? Now you can understand from on all the sides. Now behind the iris there is the posterior chamber, and behind the posterior chamber there is your lens. So this is our lens, right? Now what is lens? Look carefully. Let's define the lens. Whenever light ray comes and strikes your cornea, right? So this light is taken to your lens, right? And from this lens the light ray is passed and bent. We know that we will discuss later. So the light ray when comes and falls on your lens, this light is passed from the lens. Light passes from the lens. So we say the lens is a transparent object, right? The lens is a transparent object. Why? Because light can pass through it. If the lens become opaque, then there will be a disease that is called the cataract disease. So you know that when light ray comes, it passes the cornea, passes the pupil, passes the iris, and hits hits your lens, and the lens allow the light rays to pass through it through the vitreous body, and on the light ray will fall on the retina, right? So lens is a transparent object. Now one thing more, you know that your lens on both sides is like this. So this lens on anterior side and on posterior side, it has a convex structure, convex shape, right? So in our eye we have a concave lens. So we say on both sides the lens is concave. That's why we say it is a biconcave lens. If you look, I have a look here. This is a concave structure. Look, it has went outward, and if on this side it's also coming outward. So our lens has a concave, it is a convex structure like this, right? So on both sides it is going outside, so convex lens. So in our eye we have a convex lens, and this lens allows the light to pass through it. That's why we say, what is lens? Lens is a biconvex transparent object, right? A biconvex transparent object. This is your lens. Now the next point about lens, now let's go deeper into it. What is the location of your lens? Where is the lens located? So look carefully. First of all, a little bit anatomy of it. Look, then we will go in the structure of the lens and we will discuss that. You know that lens is located interior to the vitreous body and posterior to the iris in the patellar fossa, right? So let's write it here. Lens is located, it is located behind iris and anterior to vitreous body. In what? In the depression of the vitreous body, in the saucer depression of the vitreous body, that is called the patellar fossa. In patellar fossa. This is the exact location of your lens. Now the next thing, what is the weight of this lens? Weight. So you know that when the baby is born, his eyes are very small, and now our eyes are little bit larger. So the weight of the lens of the baby is lesser than the weight of the lens of an adult person. So if we talk about the weight of those babies from 0 to 9 years, right, that weight is 135 milligram. 135 milligram will be the weight, and the weight of the persons from 40 to 80 years, his weight of his lens is 155 milligrams, right? So this is the weight. Now what is the shape of your lens, my dear friends? Shape. So you know, here I have told you that our lens has a biconvex shape, and you can also say that the lens is round in shape. It's the very important point. This was the shape. Now next important thing about the lens is that what is the thickness of your lens? Thickness of the lens. Look carefully. Thickness means when the baby is born, what is the thickness of the lens? So from here up to here, what is the thickness, right? So when the baby is born at birth, we say at birth, what is the thickness? That is so important, friends. Its thickness is about 3.5 millimeter. It is at birth, and at its extreme. At extreme means what is the last the extreme point of the thickness of the lens? That is about 5 millimeter. 5 millimeter at its extreme. So extreme means an adult eye. An adult eye lens has a thickness of 5 millimeter, right? Then what is the diameter of your lens? Right? So diameter means like this, right? This was the thickness and this is the diameter. So its diameter is from 9 to 10 millimeter, near to 1 centimeter. So 9 to 10 millimeter is its diameter. And how many surfaces does your lens has? Surfaces. So you know that here, if this is our lens, so this surface is outward, this surface is backward. So this is anterior surface, this is posterior surface. If you look here, interior surface and posterior surface, and if you look here, this is the interior surface and that will be the posterior surface, as I have shown here, the interior surface and the posterior surface. Done. So it has interior surface and it has a posterior surface. And one thing which is very important, my dear friends, the posterior surface is little bit more convex than the interior surface. For example, if I draw the lens, here is your cornea, right? And here is your lens located. So lens is like this, right? Here, if I draw the equator line, right? This is the equator line. Now you can see the posterior surface, right? It has a more convexity. Look, and the interior surface has less convexity, right? So let me write it here. Interior surface is less convex, right? And posterior surface is more convex. Done. These were the surfaces of the lens. The next important point about the lens is that what is the nature of your lens? Nature. So you know that it allows light to pass through it. So its nature is a transparent nature. It has a transparent nature. We should know these important points about the lens, and then we will discuss inshallah about the structure of the lens in a big detail, right? How many pools does it has? How many pools does our lens has? So it has two pools, the anterior pool, right? The anterior pool and the posterior pool. So let me write it here. It has anterior pool and a posterior pool, right? Then the next part about the lens is that what is the radius of curvature? Radius of curvature. What does it mean by radius of curvature? Curvature. What does it mean by radius of curvature? Look carefully, friends, here. Let's come here. For example, this is the equator line, right? Now, from this equator line, from this central line, how much space is present here and how much space is present here? It means that how much backward the posterior surface goes and how much anterior the anterior surface goes. So the equator line, this is the equator. From equator, how much space is there in between the equator line and anterior surface, and how much space is present there in between the equator line and the posterior surface. So this is the radius of curvature. For example, if this is the central line, right, how much space is present here, how much curve is present here. If the curve is less, then the radius of curvature is less. If the curve is more, then the radius of curvature is more. So radius of curvature, we should talk about the anterior pole and the posterior pole radius of curvature. So as there are two poles and two surfaces, so anterior pole radius of curvature and posterior pole radius of curvature, and you know that very well, so look carefully. The anterior pole radius of curvature is about 10 millimeter and posterior pole radius of curvature is about 6 millimeter. So this is the radius of curvature of your lens. The next point about the lens is that the refractive index. Refractive index. What is the refractive index of a normal human eye lens? Let's take an example of something. We should first of all know what is refractive index. For example, my dear friends, if you do this experiment at home, and you know this very well, I know that if you take a glass of water, right, and you put water in this glass, right, here is H2O, and what you do, you dip a pencil, you take a pencil and dip it into the water. So what does your eyes say? Your eyes will say, if you dip this pencil into the water, your eyes will say that normally it should go straighter. Normally it should go straighter. But in case of water, it does not happen. Why? Because in the same glass of water, if you are dipping your pencil, right, here is the water again, right, and if you dip your pencil again, it will come up to here, the image will be shown straighter. But when it touches the water, the pencil will go in another direction, like this. It will be seen like this. So if you have a cup of water in your hand, right, and if you take water and dip your pen, right, so your pen will be shown a little bit curved like this. So why? Because whenever you enter from one medium into another medium, so there is a refraction, right? What is this? This is a refraction. So our lens also do this. Look carefully how. Whenever, for example, this is your lens, right? Whenever light ray strikes your lens like this, what does this lens do? The lens changes the path of the light ray, and here also the lens changes the path of the light ray. So when the light ray comes straighter and strikes the lens, and then the lens converges the light ray, look, the same situation is here. So this is called refraction. And what is the refractive index of your eye lens? So it's about 1.39. This is the refractive index of our eye. Next point. What is the power of the lens? Look, the next important point about lens is, what is the power of lens? What does it mean by power? What is power? So power of the lens means how much the lens can converge the light ray. Look carefully. If we have here two lenses, this is lens number 1, this is lens number 2, right? And what do? We put light rays on both of these lenses, right? This lens will converge this light ray at this point. This is the converging point. And about this lens has converged and the light ray at this point. So you can see that the distance between the lens and the converging point is far for the lens number 2, and the distance for the converging point for the lens number 1 is less. So we call this distance as focal length. What? Focal length. This is also we denoted from F. We know that's from physics. So this is the focal length. Now that lens, look carefully my dear friends, that lens for which the focal length is short, that lens is much powerful. What does it mean? If a lens converges the light rays near to itself, so it has a very, very good power, right? So power of lens means how much near the lens will converge, will unite these two rays, right? So this important point from here up to here is your focal length. So the lens which has a short focal length, it has a large power, right? And the lens which has long focal length, its power is less. Now what is the power of our lens? I hope it is clear to you guys. So the power of the lens, in case of our eyes, in case of if you are a doctor, so what will you say? You will say that the power of our lens is from 15 to 16 diopter, right? Diopter is a unit for the power of a human eye lens. Now look carefully, what is diopter? Let's make a very small calculation here. For example, once again, if this is a lens, right, and this is a lens number 2, okay, look carefully, this is the light ray and this is another light ray, and both of them unite at this point, right? And for this lens, both of these rays unite a little far away from the lens. So this is the union point, right? Now look carefully. Here the focal length is from here up to here, and here the focal length is here. Now what is the power of the lens? Formula for power of the lens is power of the lens is equal to what? Is equal to 1 divided by focal length, right? Okay, and we take the focal length, since focal length we take in meters, so what will happen? We will put in, okay, so we will do the calculation like this. Power is equal to what? 1 divided by F, focal length. It means that it is equal to 1 divided by meter, which is equal to diopter. So diopter is the unit for the power of your lens. Let's take an example at this point. Look, if from here up to here the focal length is 2 centimeter, and for this lens the focal length is about 10 centimeter. Now let's put these two in this formula. We will take what? Look carefully. So power of the lens is equal to what? 1 divided by focal length, which is equal to 2 centimeter, right? And we can write in this in meters. We should write this centimeter in meters. So in order to convert centimeter into meters, what should we do? We should divide this 2 by 100. So we will get 0.2 meter. Right? Now put this 0.2 meter here. So power will become 1 divided by 0.2, which will be equal to 20 diopter. 20 diopter. right? And in case of this one, the same calculation will be there. Power is equal to 1 divided by 10 centimeter, like this, right? And convert centimeter to meter. What will take? Power is equal to 1 divided by, okay, let's convert it, 10 centimeter divided by 100. So this will finish. 1 divided by 10 is equal to 0.1, right? So what we will get? We will get 1 divided by 0.1, which will be equal to your power, right? So like this we do this calculation. So look carefully. If the focal length is shorter, then the power of the lens is higher. And if the focal length is higher, more, the focal length is longer, then the power of the lens is smaller. So our eye has a power of 15 to 16 diopter, right? I hope you understand all these calculations. A little bit complicated, but no problem. If you watch the video 2 or 3 times, you will get this. So this was about the power of your lens. Now the next important thing about our lens is the accommodation of the lens, the power of accommodation. Power of accommodation. Look carefully. What does it mean? It means that how much your lens can stretch. Look carefully. This power is actually not the power of your lens, but this power is actually the power of those ciliary muscles which will stretch, which will contract which will be contract and which will pull the ciliary, the suspensory ligaments, and your lens will be stretched. Look at here, friends. Here is a lens, right? And it is, you know that it is held by suspensory ligaments, right? And these suspensory ligaments are attached to the ciliary body. There I have shown this is your ciliary body, and you know eye is a rounded structure, is a globe structure, so ciliary body is all around, and lens is also a rounded structure, and ciliary and the suspensory ligaments is also all around, like this. Now look carefully. In the ciliary body, you know that there are different type of muscles. The 3 types of muscles are present there, right? Now look carefully. Whenever these muscles will contract, they will pull the suspensory ligaments towards their self, and these suspensory ligaments will enlarge the size of your iris. Look here, of your lens. So this is the lens have been enlarged here, and these are your suspensory ligaments. I hope you are understanding me. And then there is your iris, right? And then there is your what is this? This is the muscles of your ciliary body. Now you know that I have drawn it a little broader here and here little narrower. So what does it mean? It means that here the ciliary muscles have been contracted here, right? And here the muscles are relaxed, right? Now when the muscles relax, the size of your lens shortens, right? And when the muscles contract, what will they do? On all the sides, when these muscles contract, right, they pull the suspensory ligaments. When the suspensory ligaments are pulled on all the sides, they will pull the lens to all the sides of the ciliary body, so that they increase the size of your lens, the surface area of your lens. This condition is seen when you are looking at far objects, right? Whenever you are looking at far objects, so the light rays are coming from very far place. What your nervous system do? Your nervous system send messages to the ciliary muscles. Ciliary muscles contract and they pull the lens, and the size of the lens increases, and the power of accommodation of the light rays increases, right? And whenever you are looking at the near objects, so your lens shortens and its power of accommodation shortens, right? So what is this power? This is called the power of accommodation. So the ability of what is actually the power of accommodation. How can we define it? We can define it, it is the ability of your ciliary muscles to increase or decrease the size of your lens, right? So ability of ciliary muscles to increase or decrease, right, size of lens. This is called the power of accommodation. And what is the power of the accommodation of the lens? So we take this at three different ages. What is the power of accommodation at birth? Right? So it is about 14 to 16 diopters. 14 to 16, I will write just D, which means diopter. And at 25 years, the power of accommodation is 7 to 8 diopter. 7 to 8 diopter. And at the age of 50 years, its power of accommodation is from 1 to 2 diopter. Right? So look, if you have understood this power of the lens, you can easily understand this one. How? Look carefully. Here the power is much more than this one. So as I had said here, that more power of the lens means short focal length. So here, as you can see, that the eye of a baby is very small eye. Babies have very small eye, right? And you know that the retina of the eye of the baby is very near to the lens, like this, right? So it means that when the light ray strikes the lens of the baby, its power of accommodation is very large, 14 to 16 diopter. So it will strongly converge the light ray to a very small distance, which we say the focal length will be very small. So if the power is more, the focal length is small. Here you can see at the extreme of the edge, right, the power of your lens decreases. So it means that focal length will be increased. Right. I hope you understand this. So my dear friends, the next lecture will be about the structure of the lens. So these were some basic points about the lens. Inshallah, I hope you have understand these, the basic things regarding your lens. The next lecture, see you there. We will discuss about the structure and the fibers and the layers and everything about the lens. Till then, Allah Hafiz.